So in this video, we're going to talk about determining the equation of a quadratic when we're given its roots. So to be honest, this concept itself is not anything new compared to what you might have done in grade 10. There is one sort of example, one type of roots that we might look at where you kind of never explored. The concept is there, but the math is a little bit tricky. But I'll show you a tip to sort of work around that math, and it involves radicals when our roots involve a radical, and how do we actually get that equation. So as a warm-up, this would be maybe a question you would have gotten in grade 10. So we want to determine the equation of quadratic that has the vertex minus 4 comma 12 and pass through the point 1 comma 62. So because we're given the vertex, we're going to start with our equation. So f of x is equal to, in vertex form, so you might have used x minus h, quantity squared plus k. Different teachers use different variables. Actually, in this course, later on, we'll actually switch these variables around because k has a different meaning, but this is something that you might be very familiar with, and we'll just keep it that way. So here we have the vertex is negative 4 comma 6. So we don't know the a value, you don't know the stretch factor, but here we get x minus my h is my x coordinate of my vertex, which is negative 4 squared plus k, in this case is 12. So f of x is equal to a times x plus 4 quantity squared plus 12. So how do we go off and solve for a? Well, we're given a very important piece of information in that the point, sort of the parabola goes through the point 1 comma 62. So my teaching of drawing lines in grade 9 is a line is not a line. It's an infinite set of points. And how do we derive those points? Well, it's all the combinations of x and y that make our equation true. So in other words, we plug in certain values for x and we get a certain value for y. That is how we get those points on our graph. And eventually we do infinite amount of times, all those points do look like a curve, or in grade 9, y equals mx plus b. It looks like a straight line. In grade 10, a parabola. And then we'll discover that various functions we'll study in this course. That's how we sort of get how that line works. But basically, it's all these values of x and y that make our equation true. So in this case, the value x is 1 will yield us an answer of 62. So what we're really saying here is that f of 1, in other words, x is 1, is 1 plus 4 quantity squared plus 12. And in this case, what's f of 1? And then what's the answer when x is 1? Well, the answer is 62. And I'll go off and start simplifying the right side. So that's going to be 5 squared plus 12. So 62 is equal to 25a plus 12. And then we're going to subtract 12 from both sides. So we get 50 is equal to 25a. And divide both sides for 25. Finally, we get a is 2. So therefore, the equation of the quadratic is f of x is equal to 2x plus 4 quantity squared plus 12. Okay, so that's how we would do a question like that. Similarly, if we were given an equation, so given a quadratic, and we're told what the x-intercepts are. So in this case, the x-intercepts are negative 2 and 6, and again, passes through a point 3 comma 10. So in this case, we won't start off with the vertex form because we're not given a vertex, but we'll start off with a quadratic in x-intercepts or factor form. So in this case, we're going to say f of x is equal to a. Again, that general form is x minus r and x minus s, where r and s are the roots of the quadratic. So here, one of the roots is negative 2, and here's the other root is 6. So we're going to say f of x is equal to x minus a negative 2, and x minus 6. So a here is just to simplify that, x plus 2 times x minus 6. So that's what f of x is, or that's my equation. Again, we don't know my a value. Just a quick check that I didn't make any silly mistakes. 6 minus 6 does give me 0, so that is one of the zeros. And negative 2 plus 2 does give me a 0, so that is another 0. So just a quick check there that I didn't do anything silly. And finally, just like the previous question, we're going to make use of the fact that the point 3 comma 10 passes through, the parabola passes through the point 3 comma 10. That means here the values of x and y that makes this equation true is 3 and 10. So we go off and plug that in. So here x would be 3. So here 3 plus 2, 3 minus 6. And what's f of 3? In other words, what's the answer to our function when x is 3? Well, that's where y value is. So that's going to be 10. It's equal to a 5 times a negative 3. And here we get 10 is equal to negative 15a. And dividing both sides by negative 15, we're going to get a is equal to negative 2/3. So therefore, the equation of the quadratic is f of x is equal to minus 2/3 x plus 2 x minus 6. And we could just leave it in factor form because the question itself just determine an equation. It doesn't say what form. So if it was asked to determine an equation in standard form, then we'll go off and have to expand that again to be in standard form. Thankfully, it doesn't ask for it in vertex form because then somehow we have to complete the square and get the convert that equation to a vertex form. So really the success criteria for this section is we're going to find the equation of a family of quadratic functions given its x-intercepts or its roots. And we're also determine a specific quadratic function when given one point on the function. So our warm-up has already done that. So what is a family of functions? A family of functions is a set of functions that have similar form. In other words, they share a common characteristic. The parent of the family is the equation of the family in the simplest form. So for example, y is equal to x squared is the most basic form of a parabola, and therefore it is the parent to the family of functions. For example, in this case, all parabolas that have a root, negative 2, and a positive 6. So if we go back and look at our warm-up questions, really once we got to this point, when we said that f of x is equal to a times x plus 4, coordinate squared plus 12, because we used a vertex, this in itself is a family of quadratics. Well, what is this family? In other words, how is this related? They all share the same vertex. So if we were sort of to graph this, and we might say that negative 4 and 12 might be somewhere over here. Well, there's going to be an infinite amount of parabolas that have that as a vertex. You might have a parabola that looks like that, nice and fat. You might have parabolas nice and thin. You might have parabolas that are upside down. So there's going to be an infinite amount of members of this family that share that common vertex. So that's what we mean by family. Nothing more, nothing less. Just share a common characteristic. If we want a specific member of the family, then we must be given something like a point that passes through it. Likewise, in our second example, this is also a family once we get to this point. So this defines a family of quadratics that share the same x-intercepts. So in this case, negative 2 and positive 6. So likewise, if I was to quickly maybe kind of sketch this, and we'll say that here's a root of negative 2 and here's a root of positive 6. Well, again, we're going to have an infinite amount of parabolas that pass through those or have those as x-intercepts. So again, we might have a fat one. We might have a really steep one that goes all the way down there and goes back up. Again, we might have some that are upside down. So an infinite amount of parabolas that have those x-intercepts. So all those are members of this family because they share the common characteristic of the same roots, -6, so -2 and +6. If we want a specific member of the family, then again we have to be given a specific point that passes through that parabola to get that specific member. So that's all it really is. So here might be another example. Determine the equation of a quadratic function that has a double zero. That is two identical roots at x minus 3 over 2 and passes through x minus 3. So how might we want to start off with this? Well, because we're given two roots, I might start off in factor form. So here we're going to f of x is equal to a. And in this case, it's going to be x minus r quantity squared. Well, notice that this is also like vertex form as well. And here, the roots in this case, or the root in this case is -3 over 2. So this becomes x plus 3 over 2 quantity squared. And now it's passing through a specific point, -1, 3. In other words, the combination of x equals 1, y equals 3 makes this equation true. So now we could plug in -1 for x, and that becomes a. In this case, it's going to be -1 plus 3 over 2 quantity squared. Let me make that a little bit more neat. 3 over 2 quantity squared. And again, the answer when x is -1 is 3. And going to simplify, -1 plus 3 over 2 is going to be 1/2 quantity squared. So 3 is going to be equal to, well, 1/2 squared is going to be a times 1/4. And here I'm going to multiply both sides by 4. Actually, don't need that dot. Just use the parentheses. And so here we're going to get a is equal to 12. So therefore, f of x is equal to 12 x plus 3 over 2 quantity squared. That is the equation of the quadratic. It's the equation of the quadratic. Okay, so nothing earth-shattering yet. I would argue that these are questions that could have been on your grade 10 exam if you had one. These are all fair games, and this is all really review of your knowledge of quadratics from grade 10. So now here we get to be something a lot trickier. Again, the concept itself hasn't changed. Determine the equation of a quadratic function has the roots 3 plus or minus root 5 and passes through to -12. So we get blown away by this a little bit because where might we get an answer like that? Well, from using the quadratic formula. In other words, our quadratic equation was not factorable, so therefore the roots did not pass through, were not integers, and we got something like using the quadratic formula, 3 plus or minus root 5. So how do we go about determining the equation for this? Well, because when we're told that it's roots, we just start off in factor form. So here we go, f of x is equal to a x minus r x minus s. So f of x, because we don't know what a is, well, let's start writing in that root. So here, because we wrote 1, it looks like it might be one root. Don't get tricked by that. Really, it's two roots. I'm going to write it out explicitly. One is 1 plus root 5, and the other one is 1 minus root 5. Okay, so let's plug in the first one, and it's important here that we need to conclude the bracket. In other words, this value here is r, is this entire radical. So here's going to be 3 plus root 5, and then here it's going to be x minus 3 minus root 5. Then we sort of expand or distribute the negative, and here we get a times x minus 3 minus root 5 times x minus 3 plus root 5. So how do we go off and simplify that? Because there's a radical in there, we can't add them. We can't sort of get rid of the radical. We can't do 3 minus root 5. They're not like radicals, so we can't add them. We could FOIL this, and that really is not going to be FOIL. It's a trinomial times a trinomial, and you go off and simplify it. So it will work. It will take you a while. You have to be really focused and make sure you don't make any mistakes. And in the end, you could simplify to an equation. But I'm going to show us a little trick. What we're going to do is that now that this is written out, let's look at it from a different perspective. Here, I'm going to add a set of brackets to the x minus 3, and then a set of brackets around the root 5. So really, this looks like a difference of squares. So if we let sort of like a equals x minus 3, and b equals root 5, really what we have in there, or maybe a and b is not the best, because we have a in there, so let's do instead p's and q's. So really you have p minus q and p plus q. And then beautiful part about difference of squares is sort of the p's and q's disappear, and we get here instead is p squared minus q squared. All right? So that's the trick that we're going to use and apply over here as well. This is going to be a, so I'll put this in square brackets now, x minus 3 quantity squared minus root 5 quantity squared. Okay, so taking the attribute of difference of squares, well, the first one x minus 3, I'm squaring that. Everything else is going to sort of disappear by this attribute of the difference of squares, and then finally we get minus root 5 quantity squared. So that's something nice, really nice happens, is I'll just focus on the negative root 5 first. That becomes, well, negative root 5 quantity squared is just 5. And now we could quickly expand the perfect square trinomial of x minus 3 quantity squared. So here I'll switch to round brackets now. So this is going to be x squared minus 6x plus 9 minus 5. And so eventually we're going to get a times x squared, minus 6x, so plus 9 minus 5 is going to be a plus 4. And this is what f of x is. So a little bit of work to get there, but not too bad if we kind of see the pattern in there. And now, like before, we need to calculate the value of a, or determine the a value. So here we're told that it passes 0.2, negative 12. So here we're saying that f of 2. So we're going to plug in 2. Here's a, going to be 2 squared minus 6 times 2 plus 4. And we're saying that the answer to that is 12. And I'm going to simplify it inside my brackets. So here it could be 4 minus 12 plus 4. So in this case, 12 is equal to 4 minus 12 is negative 8 plus 4 is negative 4. So it's going to be negative 4a. And then dividing both sides by negative 4, we're going to say that a is negative 3. So in this question, it does say express your answer in standard form. So we need to be careful. So let's go off and replug in a. So f of x is equal to negative 3. And what was our equation that we had over here? So negative 3 times x squared. Oh, not that one. Oh, one too high. This is the one I'm looking for. X squared minus 6x plus 4. So this is not standard form. I need to distribute the 3. So negative 3, so it's going to be negative 3x squared plus 18x minus 12. So that's our equation. So therefore f of x is equal to negative 3x squared plus 18x minus 12 is the quadratic equation of the quadratic. Okay, so that's how you do an example of that, where you have roots that contain a radical. And notice it's always going to be in that form. Something, a number plus or minus the same radical. And this is why it's nice, because we're going to really square that radical, and the radical is going to disappear. So to close this off, we just have a word problem. A water shoots out from a decorative fountain, making an arc in the shape of a parabola. Well, there's a surprise. The arc spans the distance of 6 meters from one side of the fountain to the other. The height of the water at a horizontal distance of 1 meter from the starting point is 5 meters. So always trying to, if we could visualize it, it makes things a lot better. So we're going to sketch a diagram, and I'm going to have sort of implied x and y axes. So recognize there's multiple ways to solve these word problems. And it all depends on your perspective and how you sort of define things. Okay? One thing that is implied, I would say implied, when we talk about distance, for example, height, we're implying when it says, for example, 1 meter, 5 meters high, the height of the water, horizontal distance of 1 meter from the starting point is 5 meters. So when we say 5 meters high, we're making an assumption. That 5 meters is compared to where? It's compared to the ground. So we're assuming that the ground is 0 meters. That's an assumption that we're making. Nothing says that that has to be the case. We could say that this could be compared to sea level. And if we're in Toronto, I don't know what the sea level is, but we could say that 0 meters is the sea level, and we would have a very different looking graph. The equation that would come out very different. But as long as we know what we're comparing it with, that's what it matters. So for example, we have to be relative to sea level. So in this case, the easiest thing to do is when we talk about the x-axis, is this is the ground. Just 0. Now, where is the water shooting from? Or where is this fountain? So one of the things is that the easiest thing to do is saying that the start of the fountain might be right there. Let me do that in a different color. We might say the start of the fountain is over there. So it's going to shoot water, and then the water is going to land somewhere over there. So we're told that this is 6 meters. Right? So this is where we get this information from, 6 meters. Does it have to start there? Here we're saying that x equals 0 is the start of the fountain. It's where the fountain is, or in this case, the leftmost side of the fountain. That's what we define x equals 0. It doesn't have to be. Again, we could say x equals 0 is my house. And we have to measure how far it is from my house to the fountain, and that would be the distance. We could technically do that, but it seems silly, it seems outrageous, and a lot of extra effort. So we're going to choose a point that's relative that makes sense. So in this case, I'm going to say the start of the fountain. So here, we're actually given some very implicit information. So that means that's 0. This point is 0, and this point is 6. Notice that in a parabola, you can think of it as those are my roots. So we could just start off, in this determinant equation, I could start off with f of x is equal to, I don't know what the stretch factor is, but because I know this is in factor form, I might start off with x minus r, x minus s, and here I know that one of my roots is just at 0, and the other one is at 6. So there's the start of my equation. So here, because we're sort of given a hint, or given some information that at 1 meter from the starting point, the height of the water is 5 meters. So what that means is that 1 meter out, so 1 meter out, the height of the water right there is 5 meters. So in other words, we have a point 1, 5. Okay, notice that here we start putting things into a picture and start seeing things and lay that picture on a grid. It's very like the problem that we just solved before. In other words, here when we're saying that f of 1, so that's going to be a times 1 minus 6, the answer to that is 5. So that's going to be negative 5a. So we discover, oops, not divided by a, but we're divided by negative 5. So that implies that a is equal to minus 1. So our equation is f of x is equal to negative x times x minus 6. Well, does that kind of make sense? Yes, because when x is 6, in other words, on the other side, it's 6 meters away from that start of the fountain, it should be at ground 0. So 6 minus 6 is 0, so this does make sense. So here we'll determine the maximum height of the water. So we know that the maximum height is at the vertex. So because we already have the two roots, we know that the x-coordinate of the vertex is going to be halfway in between. So 6 plus 0 over 2, which is 6 over 2, which is 3. So in order to get the height, we need to, maximum height, we need to plug in the x-coordinate of the vertex, which is going to be the same thing as f of 3, which is minus 3 times 3 minus 6, which is negative 3 times the negative 3, which is 9. So therefore, maximum height of the water is 9 meters. Okay, that's just one way to solve it. I'm just going to sort of not go off and do it, but sort of sketch another diagram. What could be, you know what, we could have viewed this in a different perspective. And so here, just draw my grid. There's nothing to say that I'm going to say the start of the fountain is actually at minus 3. I'm going to say, start at minus 3. Really what I'm saying is that the middle of the fountain is at 0. So if it's going to shoot something that's 6 meters long, it's going to end 3 meters there. Notice that here I get a very different equation, that here f of x is going to be x minus 3 times x plus 3 times a. It looks different, but we're going to get the same answer because just our perspective, or where x is related to, is different. In this example, 0 is the start of the fountain. In this example, 0 is the middle of the fountain. So if we say that, well, 1 meter in is going to be 5 meters high, well, what's the value of that coordinate? Is not 1 comma 5, but in this case, it's actually going to be negative 2 comma 5. So it's all relative to where we define things. And if we go off and do the math, we'll go get the exact same answer, where the height of this water fountain we discover here is going to be 0, 9. In other words, it's going to be 9 meters high at where the vertex is.